from the start of the product design, we should plan for the impact of what is designed on manufacturability, assembly, quality, lead times, and so on. So what would be a few tips if you had a few bullet points to give to a product designer? What would they have to keep in mind?
I think what I would say is that, if you are designing a product, make sure you think about, first thing is the end user, the customer, and the environment that the product will be used. That is probably the most important, critical. And in this case, then you realize that, okay, the parts and the product needs to be designed in a way that is going to suit the environment that is going to be used and the customer use case environment as well. Once you've achieved that, and then the rest of it is how I'm going to design this, how I'm going to test it, and how am I going to manufacture it in such a way so that it will be an excellent product at the end. Yes, and to do that, then you have to think about basically every aspect of the design that could impact the assembly process, the manufacturing process, the testing process, and so forth, reliability and quality. Once you have thought about this and you have communicated with the cross-functional teams and come up with some kind of maybe a checklist that said, okay, yeah, we did this, and maybe you can do this, and delegate it to the right teams, the right tasks that need to be done to basically cover all aspects of for example, design for reliability, design for manufacturability, design for assembly, design for testability. So once you have this kind of a setup where you're making sure that every team does their own due diligence on their areas, for example, designers that are designing for the assembly in production, they know what they need to do so that their assembly line is mistake proof. The reliability team says, okay, well, I'm going to design a reliability test plan that is going to cover all aspects of the weird situation that the product could be used in the field, that I want to make sure we test it and cover those areas. And the same way in manufacturing, they want to make sure that all the equipment is that they need to use is all calibrated, and all the team members are all trained well for doing what they're supposed to be doing. It's kind of like a football team, really. You want to make sure that everything and everyone knows the plan, knows the game, and when we push that button, start and go, then everyone is working together kind of in a cohesive way, in a way that is going to get us results.
Right. Yeah, and you covered both product design and process design. Yeah. So usually, to get back to product designers, things that usually improve at the same time cost, complexity, and the likelihood of issues in the development, the probability for quality issues, the probability for reliability issues. What are these things? Usually there's this sort of general guidelines, right? And I'm sure most product designers have heard of that, but we can go through the list quickly. The fewer parts, the better. If there's a lot of different parts and a lot of fasteners, or different ways to assemble and fix the parts to each other, obviously the more the higher the likelihood that something goes wrong somewhere in the assembly, but also later in the field, that the product somehow breaks, right? Using common parts rather than a lot of different parts is a good thing. Using standard off-the-shelf parts rather than custom design parts, that's a very big plus. Simply because a lot of these standard parts have already been made in the tens of thousands or in the millions, and all the quirks have been worked out, and right. In the best cases, you even get the reliability test results and the certification for compliance test results, and so on and so forth. And so the risks here are much lower making assembly easier. So Andrew, you mentioned mistake proofing, things like making it easy to self-locate the parts when they assemble into each other, and just remove any opportunities for let's say awkwardness, right? How do I, like, I'm gonna fumble a bit here when I put this together. So
And
can
it
I
makes sure
just,
there's only one way to assemble.
yeah, like assemble from top to bottom,
Right.
make sure that it cannot be put the wrong way, like it cannot, this, if there's a risk,
Exactly.
maybe put a pin or something to make it very obviously impossible. So okay, okay, that's the right way. Clock. Make it like press fit, make it with some kind of click that's pretty obvious. And
Right.
all of these are very, very
Exactly.
good, very, very, very good approaches.